Okay, I guess I'll get started. It was a short 2 minutes. So, while the last people are settling in, let's begin. This time I'm going to talk about property-based testing in PHP. If you're like me, the first time I saw the term property-based testing, I was like, oh, what does that even mean? To me, properties are like fields on PHP classes. So what does that have to do with testing? Right? So I don't know. Well, let's see. Oh no. The lag. I heard about that. Right. So I enjoy looking into other fields of programming in areas where I'm not at home every day, outside of my comfort zone. Because there's so much to learn there, and there are so many things to pick up and take and integrate into where I work, with it's mostly Magento, right? One of the places that I found myself looking at other ecosystems was a programming language called Clojure. And I won't talk about Clojure right now, but I like talking about Clojure, but that's for a different time. But it's Clojure where for the first time I encountered property-based testing. However, when I saw that term property-based testing there, and all the people in Clojure, who are really smart people by the way, right? And they liked it, I was like, oh, this is interesting. Like, I love testing. What is this about? And what I was reading seemed to make a lot of sense. But it isn't actually Clojure where property-based testing was invented. Property-based testing was invented in the Haskell community. Now, Haskell is a language I am not familiar with. I have great respect for it, but it's a pretty foreign book for me. I did a workshop once or twice, but I never really felt at home there. But that's where property-based testing was invented by this person here, Professor John Hughes. He is professor of computer science at the University of Chalmers in Göteborg, Sweden. And he released a tool called QuickCheck in 1999. So that's where property-based testing originated. So it's quite a mature technology. And since then, QuickCheck has been ported into almost any language you can think of. JavaScript, TypeScript, Java, C++, .NET, all the languages, Ruby, Python, and of course also PHP. And below his little picture here that I stole from his website, there's one of his most famous quotes, which is, don't write tests, generate them. Now, in PHP, we can't generate the whole tests in a sensible way. We still have to do some writing, right? But there certainly is a lot of generation involved. So, what's this about? What is property-based testing actually? Let's get a bit more concrete. So, on the one hand, we have example-based testing. That's what I was familiar with mostly before property-based testing. In example-based testing, I think of an example input to a function that I'm writing. Maybe it's a number or an email address or something, right? And then in my test, I call the function with my example input. And then in my head, I manually think of what's the result I expect, right? And then I compare the result of the function to what I expect. And if that works, great, my function is correct. And if I'm really good, I might think of one more example, like an edge case, something very big, maybe positive infinity, okay? Or maybe something very small, like 0 or negative infinity, or maybe, a big, long email address or something like that. And if that also works, probably my function is correct. Unfortunately, there are still bugs in my code, right? So these examples, even though I try to be good and use multiple examples, they don't cover the whole space of possible states in my algorithm. There are bugs, maybe not as much as without testing, but still. And that's where property-based testing comes into play. With property-based testing, instead of thinking of individual examples that I pick and call my method with, instead I think about a whole range of possible inputs. So I can say, my function that I'm writing here, it takes not just one email address, right? It takes any email address. That's a string, but is it any string? Or is it just a subset, strings that are not empty? Or maybe they can't be larger than a certain size? Or maybe with numbers, is it ints? Is it decimals? Is it like maybe only small integers? Or maybe with objects, maybe it's just logged in customers, or I think about the possible range of inputs, not just one specific example. And then I let the computer generate all those example values that I want to test. Out of all the range, I let the computer pick examples. And the computer is pretty good at generating values. So I can easily tell the computer to generate, 100 or 200 or 500 examples and run my test function. And then, after I call the method that I'm testing with these generated values in my test, I want to check that it actually worked. But the problem is, this time I have generated values, so I can't pre-calculate the result that I'm expecting. So I have to find a different way to check if my function operates correctly. But I can't use the concrete value, and that's why I have to check for if a certain property about the result is true. And I'll talk more about what these properties that we can check for, what they are, how we can find these properties. And then I let the algorithm run and QuickCheck generate values and call my function. And if for one of these generated values, one of the inputs, this property that I defined doesn't hold true, in that case, QuickCheck does something pretty awesome and very important that's part of the process, namely, a generated value might be rather large. And if you ever try to debug why an error happens with an array of, 10,000 records, it's not fun, right? Like, which one of these 10,000 characters maybe caused this exception? Not fun. So QuickCheck, as soon as it finds a failure, it tries to shrink that generated value. And how the value is shrunken depends on the value type. So for strings, for example, it makes the string shorter, but also each individual character is shrunk towards a lower code point, so towards normal ASCII characters. And numbers, you tend to shrink towards 0, right? And arrays are shortened. So it shrinks the input and runs the test again. And if it still fails, it shrinks the values again and runs it again. And it continues with this process until the test no longer fails or until QuickCheck no longer knows how to shrink the value further. And then it reports the smallest shrunken value that it found that still caused the error, the failure. That's what it reports. So instead of getting an array with 10,000 records, I maybe get an array with 2 records. And that's actually very useful. I can work with this. I can debug the function. So, what are the advantages of property-based tests? Well, when I write a normal PHP unit test, I usually have a data provider if I have many examples, or I write several tests. And oftentimes, many of these example-based tests can be replaced by a single or maybe 2 property-based tests. Because, well, I generate much more examples anyway than I could ever write manually. And having fewer tests, but with the same amount of coverage and thoroughness means they're more maintainable, right? Because I don't have to add many tests if the code changes. So that's good. Also, well, to be honest, with example-based tests, I don't actually find bugs, right? They help me write my code, and sometimes I write a test that fails, but almost always I know in advance that it's going to fail. It doesn't actually find a bug. They might prohibit regressions from happening, but that again is just not like finding new bugs in existing code. But with property-based tests, they actually find bugs. It's almost annoying, but it's very useful too, right? It's really cool. So, with example-based tests, they're actually pretty good for simple systems, right? If I have a simple function, I can get good coverage and be pretty confident that it works with example-based tests. But as soon as I take multiple simple functions and combine them into more complex systems, suddenly that's where these bugs start to creep in, right? because I can only think of a limited amount of examples and write them manually, but the space of possible states of interaction between all those simple functions and systems becomes more and more complex. That means the whole problem space gets populated more and more sparse by my examples, right? And that's why property-based testing is more efficient on complex systems, because I can cover this whole range of possible states more efficiently. Okay. Property-based tests are also used for black box systems. So John Hughes, the inventor, tested, he's got a company, he founded a company that provides testing as a service. And one of their clients was Dropbox, right? The file sharing synchronization company. And he tested Dropbox not by getting access to Dropbox source code and writing tests and analyzing the source code, but instead he used property-based testing, and he used the implementation of QuickCheck in Erlang. Right? He had no idea what it actually is, and he still uncovered multiple bugs. So we can test any system, if we have the source code or not, with property-based tests. We can use front-end tests to test, UI errors. We can test for pretty much anything that we can write properties for. And finally, one of the often overlooked benefits of property-based testings that I found very valuable is that writing property-based tests helps me think about the system that I'm writing in a deeper way and on a deeper level. And that's been really useful. I believe I've become a better developer just because it trained me in thinking about the problem in a different way. So, let's have a look at a concrete example. Oh, there it is. Oh, first, before we look at it, there are two PHP implementations of QuickCheck, actually. The first one is called PHP QuickCheck. That's the one that I'm using currently. It's great. It's by a guy called Stefan Österreicher. He's from Austria. And he ported it from Clojure to PHP. And it's a very nice implementation. Prior to using QuickCheck, I use Eris a lot. Eris is quicker, actually. But it's a simpler implementation. And especially in the shrinking area, it doesn't deliver as nice results. And it used to be the case that PHP QuickCheck had a bit of a problematic implementation, so I always ran out of memory quickly running the tests. But that's been fixed. And the author is very responsive to issues, and so it's great. I really recommend using this. And I also based all the examples in the slides on PHP QuickCheck. That said, Eris also is a really nice library, and yeah, if you have speed issues, maybe it's good enough. You could try this. Okay, so how does it actually look? Let's look at some code. So first of all, you can see this class is a regular PHP unit test class. It extends the PHP unit test case abstract class, nothing special there. So we can use PHP unit to run those tests. The test method itself is also a regular PHP unit test method, right? It starts with the keyword test, and then we can describe the name of, what are we doing here? Now, inside of the test method, we first of all define the property using the static method call property for all. So, property is a class that is imported out of the QuickCheck library. And for all means, so for all the inputs for this function, this property should be true. And for all takes two arguments. The first argument is an array with generators. So here in this example test, I'm just testing something about uppercasing strings with multi-byte stir to upper. But string to upper just takes a single argument, right? So that's just a single generator here, a string generator. But we can also define custom generators, and there are many generators that are included with QuickCheck. All the basic data types like integers and positive ints and booleans and arrays and maps and all that stuff's covered. And then I can take those and combine them into custom generators for more complex data structures and also for objects. But I'll show an example of that later on too. So that's the first argument, is all the generators that I need. Here, just one. And then the second argument is a function. And that function takes the generated argument and then defines the property. So here, this tests that if I uppercase a string, it says, well, the length shouldn't change when the string is uppercased, right? That's something that I believe to be true, right? So here I'm comparing if the length of the input is the same as the length of the uppercase input, then the function returns true. Otherwise, it returns false. That's pretty simple, right? And then finally, I call this assert that. So that's the standard base PHP unit assertion method. And then I pass in the property and a special constraint called property constraint check. And I can call the number of tests that it should execute, right? So I think by default it executes 100 tests, but here I say, oh, let's just do 200 or however many I want. How many values to generate? How often should that function be called? And if it finds a failure, and it turns out this property is not true, right? It fails. I get something that looks like this. So failed asserting that property is true, and I want to highlight a few aspects of this output, right? So I ran the test multiple times, so here are two examples. So first of all, I see the number of test runs until the failure occurred. So here, as you can see, it's 7 and 9, so it's different. And the reason is, well, the input that it generates is random. So yeah, some fail earlier, sometimes fails later. But if I have a test and it fails, the worst thing is a flaky test that sometimes fails and sometimes it doesn't, like a non-reproducible test. So that's the reason why the next thing that's reported is the seed that the random number generator is seeded with. With this seed, I can rerun the exact same generated values. So just in case, that makes the whole thing reproducible. And then finally, we also get the smallest shrunken value that caused the error. So you can see here, it's in the top example, it's some weird Unicode character, and then a null byte. So the second time it fails with a null byte, a weird Unicode character, and another null byte. We don't see what was the original string that first caused the exception, right? That might have been much longer. But 2 or 3 characters, that's probably pretty easy to debug, right? Okay. So, when can we use property-based testing? Well, I always thought I was pretty early with testing, doing TDD, writing my tests first, right? So I first write a test, and then write the code, and then I refactor, red-green refactor, the typical TDD loop. Turns out, tests can be useful even earlier in the design phase. And I'll talk more about that later during this presentation. So I can use property-based testing during design. I can also use property-based testing during the implementation, kind of like TDD. There we go. I can also use property-based tests after implementation. Almost all the authorities that I know agree that writing tests after the implementation is usually not very useful. And one of the reasons is that once I write some code, I'm very biased. It's just how our brains are wired, right? It's really tricky to think of values that don't fit into the pattern that I shaped in the code, right? That's, oh, I have to watch out here. It's just natural. Maybe I could write tests for code somebody else wrote, or somebody else could write tests for my code if I don't look at that code too closely. But normally, that's a problem. But with property-based tests, because the generators don't care, they don't look at the code, they just generate the input values, right? So I avoid a lot of that bias problem. And also, thinking about the properties on the steeper level of thinking also helps not running into the same issues. So it's actually very valuable writing the tests after the implementation. It's totally an option using property-based tests. I'm not forced to write the tests first in the same hard manner as with example-based tests. A common use case for property-based testing is reproducing a bug. So who ever had a user report a bug or users report bugs and it's like, I can't reproduce that. It's impossible to reproduce. Anybody happen to that? Yeah, okay, yeah, a few hands here. I think actually there are more. But it happens to me all the time, right? It works on my machine. I don't know what you're doing. So I can write a property that is exactly a property that bug doesn't happen. So I met a guy at a conference who wrote property-based test for React JavaScript front-end. The tests were actually written in Clojure, so black box testing, right? Property-based tests. And at one point in time, scrolling stopped working in their app, and they couldn't reproduce it. Right? But with property-based testing, he wrote a property that said, okay, I can scroll. And then the properties he generated with the generators were actions that used it. You know, click this button, do this link, sort, whatever. And then he let those properties be executed and applied them to the page with a headless browser. And QuickTest was able to reproduce the bug and report the exact sequence of operations that led to that bug. Right? So that turns out that's quite a common operation to reproduce bugs. It's actually pretty useful. Okay, so where's the problem? Right? Everything's great with property-based testing. Well, the problem is coming up with good properties. That I found that really hard at first. When I started writing property-based tests, I always was like, okay, so now I've got a generator. That part was easy, and now what do I do exactly? And I always was very tempted to start re-implementing the code that I'm testing in my test, so I can check the output value like I was used to with example-based tests. But that's not a good thing to do. So I want to talk about a strategy or strategies we can follow to figure out good properties to test, right? And I'll give some examples. And that's pretty much most of the remainder of the talk. Like, how can I find properties to test if I don't want to test concrete values? Okay. So first of all, we have algebraic properties. So these are more like mathematical properties, and they mostly apply to pure functions. So functions that don't have any side effects, like sending an email, right, or something like that. But rather something where I supply inputs and then I get some outputs back. They sometimes also work for other functions, and to be honest, I never was able to use all of them. Sometimes I'm able to use one or two of these properties for what I'm writing, but it's a short list. I have it in my head, and I just go through it and see if I can somehow use one of these properties. So first, maybe, does the algorithm reverse? So the traditional example there would be, if I can serialize something, well, you know, I generate a value, I call my function to serialize it, and then later, if I unserialize it again, I should have the input value again. So then I can call it again. So I don't have to re-implement the serialization. Instead, I just do the reversing of the operation and compare that to the input, right? So sometimes that works. Sometimes it doesn't work. For example, with sorting, I can't reverse the sorting to get the original order again, right? But just see if it works. Then there's possibly, if my algorithm takes an array as an input function, does the output depend on the order of elements in the array? If yes, maybe there are some interesting properties there. Maybe I'm imploding them. Maybe the properties only apply if the array is in a certain structure, or it depends on the elements. But sometimes there are some interesting properties there. For example, sorting, it doesn't depend on it. Then I can take the input array, sort it, and then I can also sort the reverse of the input array, and the result still should be the same, right? That would be a nice property. Right. Another possibility is if the input, if I have multiple inputs and it's a binary operation, if I can apply that to like group them in different ways. So if I take A and B and apply my function and then take that result and apply it to C, will that be the same output as if I have B and C, apply that to my function, and then apply the result with A? Right? So is it associative, basically? So for example, that would be the traditional multiplication, addition, yeah, definitely associative. Merging of an array or customer quotes, that's mostly associative under some conditions, if there are no duplicate keys, right? So again, sometimes useful. Is it commutative? Is A plus B the same as B plus A? Do I have an identity value, like an empty string or an empty array? If I concatenate an empty string, it's still the same string. Those kind of properties. And finally, it's oftentimes useful to check if my function is idempotent. Can I call it multiple times without the result changing? Then that's a nice property to test too. But again, as I said, these properties don't always apply, and it's just a nice thing to check for. So what else can we check? Well, we can check functionality-based tests, properties. So this is actually pretty close to TDD, and that's what I mostly use, to be honest. So this is actually also where I have to really watch myself not to re-implement the functionality that I'm testing. For example, let's say I want to test the ls command line utility, right? So what does ls do? It takes a directory or multiple directories, and then it lists the contents, right? Simple enough. So I would generate files or file names and directory names, and then I would call ls. But now to test the output, I don't want to check and list the contents of the directory, but instead I could, for example, count the number of files that I will generate and check the number of items reported by ls match. Right? So the important thing is I don't want to re-implement the functionality there. Right. Now, commerce is very stateful. Most of the things that I do in Magento are also stateful, meaning what I can or can't do, or the outcome of one operation, depends on what was done before, right? What is something in the cart? Was the quantity changed? Was it removed again? Is the customer logged in? Has he purchased something? You know, all these different things. Is the newsletter subscribed? So I have to do multiple things to get to where I'm at. That's a stateful system. Now, there's another way that's commonly used to test stateful systems with property-based testing, which is called modeling. And I'm using model now not in the Magento ORM model sense, but rather in the model is a small replica of the real system. It's like a fake. So it doesn't use a database, it doesn't use an API. Instead, it simply uses in-memory storage, right? And only has methods that we can call. But it covers all the functionality that I want to test. So the idea here is we first create a model of the system, and then we use the generator to generate actions that I can perform on the system. And then I apply those actions to both the model and the real system, and then finally I can compare the state of my system to the state of my model, and if they're the same, everything is okay. But if they differ, then either my model's wrong or my system is wrong. So how can we use this? And this is where this property-based testing during design comes into play. So for new systems, I start by creating the model. And creating the model first helps me learn a lot about the system that I'm actually planning. For existing systems, my model will only contain part of all the functionality, only the parts I want to test, right? Just the required parts. So it's a partial model. And then I develop the model, and again, while developing the model, because it's code, I use property-based testing, so similar to TDD. And then I learn, and I discover all the things I forgot while planning. And then, okay, oh yeah, I still have to do this, so I build the model, and then finally, once that's complete, I use the model to compare to the real system. So this is a little diagram that I built, trying to come up with a way to visualize how I create those models. So first I spend some time thinking and planning. And after that, I think about, first of all, what are the operations that I have to be able to do with my system? And then I take one of those operations. Usually there's a natural first operation, and then I create a generator for it. Then I write a test for it, and then I create the model. And then I pick the next operation, write a generator, write a test, expand the model, and so on, and continue until the model is complete. So for example, at the moment I'm actually writing a downloadable product feature, not for Magento, but for a different system, but doesn't matter because property-based testing isn't dependent on a specific system. Just imagine Magento didn't have downloadable products. This would be one way to build this, right? So it's actually quite a nice example. And first of all, I thought, okay, let's plan this out. What would I want to do? I want to be able to create a downloadable product, add files to it. I want to be able to replace files, remove files, as an admin. I want to be able to delete the product, but if I delete it, customers who already purchased it probably should be able to continue download their products. And I also want to be able to completely remove it and not care about the customers. And as a customer, I want to be able to purchase the product and download it and list the files that are available for download, right? And maybe also some reporting and so on. Okay, so these are the actions. Now, step first, I want to build a generator for the action. So the first action that I want to generate, oh, 1 second. Before I continue there and show you the example for the generator, I nowadays tend to encode the actions as an array. As you'll see, it's very simple. And then I write the test, and this is what such a generator would look like. So I want to generate, my first action is the create downloadable product action, right? So what do I need to create a downloadable product? Well, I need a file, and I need a label for the file to show to the customer, right? So to create an action, I want to return an array. And to indicate it's a create action, I just write the string create as the first entry in the array. And then I want to have a file in there and the label. That's all the information I need to create it. So in order to generate that data, this is how I would use multiple things, combine multiple generators into one, into a custom generator kind of. So I generate a tuple, so an array with a fixed length, and each entry has a certain meaning. And tuples, the tuples generator, takes several other generators as an argument. So here, I generate a file name, that's a string, can't be empty. I generate some contents, that's also just a string, maybe it's empty. And I generate a label. And then all generators provide a map function, which then takes a closure, which will take the argument. So here's my tuple, and with a file, the contents and the label, and then I can somehow transform it, right? I can create an object, I can create a file, and I can return it for whatever data my function that I'm testing takes. So, then I write the test. I have property for all. Here's my action generator. And then in my test function, I instantiate my model, the downloadable product model. I apply the action to the function, so that's just calling a create method. And finally, I decided to check if this works. I'll list all the files, all the labels of the files in the model, and compare them to the expected result. So here, that create action 2, that's the last item in the create array, right? So that's my property. And because the test fails, I have to implement the model. This is how it looks like. It's just a simple method. You can see I don't actually do anything with the model. I simply drop it into an in-memory array, right? It's a fake, but it still has all the operations. And then I pick the next action to generate, like add a file, and so on and so on. Create a generator, write the test, add it to the model. Repeat with all the others, but all the time I'm learning about the system that I'm building. It took me about half a day to build the model for the downloadable product thing. And when the model is complete, then I start implementing the real system. Right? So the main benefit is the learning. But then once my system is complete, I don't only have the learning, but now I also have the action generators and the model to test my system, like I described earlier, right? Generate random lists of operations and apply them to both systems and compare the state. So, in summary, I have a couple of things that I wanted to transfer with this talk. So first of all, it's such a big world. I have so much to learn from other areas, be it hardware programming, be it, space travel, be it whatever. It's all the areas where development is happening. We can learn from them. We can take the disciplines that are developed there and start using them in our areas, because a lot of them are incredibly useful and valuable and solve problems we too have. Right? And that's something also that keeps me engaged and makes fun, not makes fun of, but makes development fun. Right? Okay. Secondly, related, learning these new skills. I always feel like an absolute beginner when I start learning something like that. And that's actually kind of healthy, probably. Feeling like a beginner, even after years of doing something, it's good to go back to feeling as a beginner again and starting new. And it's also a great feeling becoming better at something. So I really try to be kind with myself. And at first, if I feel stupid again, No problem, right? It's okay. I want to be gentle with myself, and I think it's important to remind each other to be gentle with each other if something doesn't work out at first. But persist, right? Just continue doing it, and it'll start working. Because the people who came up with it, they're so smart. If it works for them, probably it'll work for me too, right? I just need to spend some time practicing. Good. And finally, I want to say property-based testing is a really useful tool to make robust systems. Systems that work correctly and do it well. Don't expose a lot of bugs. And it also facilitates learning a better way to think. Okay, so finally, my reason to come here also, I've got the subscription service. If you're not familiar with it, mage2.tv, that's the domain name. It's almost 24 hours of developer screencasts for Magento 2 development. If you're not familiar with it, please go ahead and check that out. Okay, thank you for your attention. It's been an honor.